Hello, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. This is called minimum time to repair cars. So we're given a list of ints, which is called ranks, and then some int, which is cars. The list of int is going to be, it's going to have at most 100k elements. Car is just some like 1 to a million number. And all the elements inside are like 1 to 100. So let's see what it wants. So this is what we are given: a mechanic with rank R. Wait, a mechanic with, right, so the ranks are the mechanics. So a mechanic with rank R can repair n cars in that amount of time. So you're also given an integer cars. So that represents the total number of cars waiting in the garage here. So return the minimum time taken to repair all the cars. So all the mechanics can repair the cars simultaneously. Right, so...
I didn't get that.
What?
Could you try again?
Yeah, sorry about that. Yep, sorry about that. Yeah, so we have... So if you look at this example, we have ranks. So like this. And then we have 10 cars, and like we basically want to find a way to delegate these cars like to these people, so that so that the maximum time is like the mechanic that takes the maximum time to finish is the minimum. Well, again, it kind of goes back to like the daily questions topic at the moment, which is the decision problem. So instead of returning the minimum time, which is quite hard to just solve straight away, what if we ask, can we solve it in X amount of time? And if we can solve it in X amount of time, we can solve it in X plus 1 amount of time. And like to solve X amount, well, that means we know exactly like what n we want for each mechanic, right? So that means we can we can just assign cars that way and see if at the end we can assign all the cars. So yeah, so it is just another decision problem, like turning into a decision problem and then doing binary search on it. So of course we need a Boolean function. So that would be time, which is some int. So of course we need our Boolean function, and then we just write our binary search first. So what is our left and right bound? If all of them are 1 and there's only one car, well, this would be 1 times 1 squared, right? So that means the least amount of time we need is like at least 1 minute. What is the most? So if all of them are ranked 100 and the number of cars are a million, well, that means so that means, so this is 100, and wait, actually, we need to calculate this. So if all of them are 100, so how many can we have? We can only have like one mechanic as well. So we have to actually consider that. So if we have one mechanic, n is n cars, and we have a million. We actually need a very big number here, because like imagine we only have one mechanic, and it takes it takes like well it like if it has a rank of R, like this R is going to be maximized, and like it will have to fix all the cars by by themselves as well. So so that's why like there's a million squared here. So how many zeros actually? So like this is going to be like 10 to the power of 6. It's going to be 10 to the power of 2. So we are going to have 10 to the power of 14. Yeah, that's a huge number. But again, we're doing binary search, so like the size of this number doesn't really matter. Yeah, so you can just do 1e14. And then, so while L, again, just write our usual wait, if none of them passes, it will definitely pass eventually, I think. Yeah, it will definitely pass eventually. We got all the stuff in here. Yeah. So, again, so if it is possible with m amount of time, that means it is possible. So we set the answer, like set the current minimum answer to m, and then we have to we want to look like at the times below m. Otherwise, we want to look at the time after m. So we can do that, and then we just return answer here. So now we just have to solve this part. Well, this part is also not hard to solve. Well, because like we can just have number of cars. So maybe like fixed cars count. Set it as 0 first, and now so for seeing cars, well, one thing I noticed from yesterday's solution is that like you can see that it is not that fast, right? Even though like I'm running nlogn, I think it is like mostly because other people are they're returning early here, so that actually saves a lot of time. So yeah, I'll do that as well today. I think it's better code. Yeah. So fixed cars count. So what do we want to add? So if we have the given time, so we have the given time, and we have the given rank. We want to know this, right? So what we can do is we can do n is equal to t divided by r, and then we can square root it. So we can do square root of the time divided by r, which is the rank of the mechanic. It should be rank actually. Oops. Yeah. Yeah, it should be the rank, and we might also want to turn some of these into floats. I think. Is it double or float? I think it's float in Python. Yeah, so float time and float r. Just do that, and then we do want to turn it into an int here. So like if we have like 5.1, like if the mechanic can fix 5.1 cars, well, it can only fix 5 cars. So we have that, and then we can just check if fixed cars count is larger or equal to cars. So that's the total number of cars. We can return true, and if we have run through this whole like all the ranks and none of them works, we want to return false. The only thing I'm worried about is like whether the floating point error would call up here. Hopefully not. Okay. Yeah. So yeah, we solved the problem. Yeah. I think this problem, it might not be the easiest to see, but then I think like the theme of the current daily questions gave it away. But yeah, thanks for watching, and I'll see you tomorrow. Bye.